Sure. Sure. See this question better. See whether you can give me the answer or not. A clock shows the time. The clock shows the time 8 hours 35 minutes 8 hours 35 minutes 45 seconds. Okay, find the time when observed in a 10 minute. Come on, tell me the answer.
325 325 minutes and 3 hours 25 minutes and 15 seconds.
25, huh?
Sir?
25 minutes, huh?
Yes, sir. Okay, 24, sorry. 45 seconds. Yes, sir.
Isn't it?
Yes, sir.
We'll
Yes,
be
sir.
writing this one as what, beta? 11 hours.
60.
11 hours. 59 minutes.
Okay, yes.
60 seconds.
60 seconds. Yes, sir.
Minus,
yes, sir.
this is 08, 35 minutes, 45 seconds.
So whenever seconds comes into place, 59 these colors.
Yeah, 59 this score.
Okay.
Isn't it? Because 11 hours, 59 minutes, 1 minute is left. That will be in seconds, 60 seconds.
Yes, sir. Yes, sir.
So 11 minus 8?
3, sir.
3 hours. So this is 3 hours. 59 minus
35, 24.
24 minutes, comma. 60 minus 45?
15 seconds.
15 seconds. So this will be the answer. Yeah.
Yes, sir.
Sure. Let us try to talk about next topic, beta. Keep the heading. Spherical mirrors. Okay.
Yes, sir.
Spherical mirrors. What is spherical mirror, beta? Spherical mirror is actually a small part of an hollow sphere, beta, whose once polished, isn't it?
Yes, sir.
So if inner surface is polished, it is known as of your concave. If outer surface is being polished, it will be called as of your convex. If inner surface is being polished, then its outer surface will become for me reflecting, beta.
Yes, sir.
Outer surface is silvered, then its inner surface will be becoming reflecting. Then that will be called as of what? Concave mirror, isn't it?
Yes, sir.
Let me take the diagram for this one. This one is your spherical mirror like this. Okay. So in this one, if I'm taking one small part right now, see here. This is the center, beta. This is known as of your center of curvature. That is nothing but of your C. The distance from the center to this point, this is the center of this mirror. This one is known as of your pole. Okay. If it is covered on outer side, this one is known as what, beta? Polished surface. Yes. So if it is silvered on the outer side, that is known as of a polished surface. Inner surface will be reflecting. This will be your reflecting. And this one is called as of your polished.
Sir, I'll just send you the portion, sir.
Yeah.
Yes.
Such type of your mirror is called what, beta? Concave mirror. Concave mirror. Okay.
I sent it, sir.
Yeah, fine. Now, if inner surface is silvered, then beta?
Convex, sir. The outer surface will do.
Yeah. Refraction, critical angle, total reflection, application of total reflection, refraction, spherical surface. So fast it is.
Yes, sir.
Okay, so we'll make it fast first, better then.
Okay.
Refraction beta. Now outer surface, if it is silver, that is known as of your concave. If inner surface is silvered right now, now this one is of your inner surface. If it is silvered inner surface, and this will be the pole of this mirror beta. This will be the P.
Yes, sir.
So such type of a mirror is called as of what beta? Convex mirror. Such type of a mirror is called what for me? Convex mirror. Is it clear?
Yes, sir.
So at that time, this side will be what? Reflecting. This side will be your reflecting, and this one is known as of your polished. Okay.
Yes, sir.
So this is the center. The distance between this center to this pole is known as of your capital R. That is radius of your curvature. Okay. So if I'm giving
Yes.
the name for this one from here to here, if this is your A, this will be your B, and if this is your X, this will be equal to your Y. Okay.
Yes, sir.
Now what is P here right now? P is nothing but what for me? Pole of your mirror. P is your pole of your mirror. C is your center of curvature. Center of curvature. And capital R is nothing but what beta? Radius of curvature. Radius of your curvature. Isn't it? Now what
Yes.
is A to B beta? A to B is known as what? A to B is your concave mirror. A to B is your concave mirror, and your X and Y will be what beta? Convex.
Convex.
This will be your convex mirror. Is that clear?
Yes, sir.
Sure. See, for marginal rays, if I'm talking about, what do you mean by marginal rays? The rays which are at the margin of your mirror. At the margin of your mirror, they are called as of your marginal rays. Right now, say for example, for this one, if I'm taking like this. Okay, if silvered on the outer side like this. Type of a mirror?
Concave, sir.
Concave mirror. This axis is known as of your what? Principal axis.
Principal axis.
This one is known as of your principal axis. Okay, and this is the
Yes.
center of this one beta. Center of curvature is C. And whenever you are drawing the normal, make sure that center of curvature nunche draw normal draw cheyala. Is that clear for you?
Yes.
If I'm taking the ray of light on this one, see, this is the marginal rays. Marginal rays means the ray which is being very far from the principal axis. That is
Yes.
called as of your marginal ray. The ray which is passing through the center of curvature. The ray which is passing through the center of your curvature. That is called as of your like this.
Yes.
This will be the normal bit. This will be your normal. The ray which is being cutting right now. So this is nothing but of your what? Angle of your incidence.
Yes.
This is your center of curvature. That is nothing but of a C. The ray which is very far from the principal axis, that is known as of your marginal rays part affiliation. Now see here, if I'm taking this angle of your incidence I as of your theta, with whatever angle it is being incident, with the same angle it will be reflected back beta. Like say this will be the ray of light here, right? Isn't it? So this one will
Yes.
be equal to your theta. Is that clear? This
Yes.
one, this yellow line is nothing but what beta? Normal. Make sure that normal must pass through always. Must pass through what? Through your center of curvature. Through your center of your curvature. That is nothing but C.
Yes, sir.
Now this is the ray of light which is coming parallel. This is your angle of incidence theta. Angle of reflection is also theta. What you do is drop a perpendicular right now here for this one. This makes an angle of your theta. The distance from here to here, this will be the radius of curvature beta. So this will be r by 2 and this one is also your r by 2. Clear?
Yes, sir.
Clear? Isn't it? So total
Yes.
distance from C to this point, the where the ray of light has been striking, there is total radius of curvature r gravity. So center exactly that will be exactly at the center. That is the reason I'm taking that one as r by 2 and r by 2 part of relation.
Okay,
Clear?
sir.
Okay.
Yes.
So that ray I'm taking right now, this one as of your r by 2, and this point I'm taking, say for example, some B. Okay, and this is the pole. Now from the figure, if I'm writing cos theta beta, so cos theta will be equal to your r by 2 divided by BC. This one, cos theta. Clear?
Yes, sir.
Now what will be the value of a BC beta? B to C will be equal to your r by 2 into your cos theta. So this will be the value of your BC. See the diagram? B to C
Yes, sir.
equals your r by 2 cos theta part of relation. So therefore,
Yes.
BP will be equal to how much beta? BP will be equal to your, that will be equal to your CP minus of your BC.
BC. Yes, sir.
CP is how much beta? C to P will be what? Radius of curvature. That is nothing
Yes, sir.
but r minus B to C is nothing but r by your 2 into your cos theta.
Cos theta.
Nothing but of your B to P. This B to P is known as of your focal length because B will be the focus for that one. Okay, so BP is known as of what for me? What? Focal length. That is known as of your focal length. So B to P will be what beta? Focal length. So from here to here, this distance will be equal to your F. The distance from the center to the pole, this will be equal to your radius of curvature. That is nothing but of your capital R. So B to P will be equal to how much beta? B to P will be equal to how much right now for me? B to P is known as of your principal axis. This is a basic formula. So B to P is equal to your R minus of your R by 2 into 2 cos theta. Now see for paraxial rays, theta is very, very small. That means it approaches to be 0. So therefore, cos theta will be approximated to your 1.
Okay, sir.
Okay, so B will be
Yes.
equal to for me. Then B will be focus. Then B will be the focus. So therefore, I can write now BP will be equal to how much beta? Therefore, this point BP will be equal to R minus R by 2 into cos theta value is how much for me? 1. So that means this value
Yes.
will become for me how much beta? R minus of your R by 2. That is 1 minus 1 by 2 will be equal to how much for me? R by 2.
Yes.
So now this focal length will be equal to your how much for me? R by 2. So the relation between the focal length and the radius of curvature is how much for me beta? R by 2.
R by
Our radius of curvature is equals to 2 times.
2 times of focal.
This is applicable only for the paraxial rays. That means when theta is very, very small, like 2 degree, 3 degree, 5 degree, 8 degree, below 10 degrees, then only we'll be using this formula. If it is 30 degrees, 20 degrees, 60 degrees, then the focal length can be calculated with the formula R minus of R by 2 into your cos theta. Is that clear?
Yes, sir.
That means for a concave mirror or convex mirror, the relation between the radius of curvature and the focal length will be equal to how much beta? F is equals to R by 2, or radius of curvature will be equal to your 2 times of your F. Is that clear? Chalo, next
Yes,
one.
sir.
Next one is about your mirror formula. Mirror formula. So again, same condition right now. This will be your principal axis, and if it
Yes.
is good on the outer side, that will be your concave mirror. This will be the pole, that is nothing but of your P. And the object is somewhere here. Wait. This is your object, and this is your center of curvature C. Okay, a ray of light is being incident from your where beta? Object. From your object when a ray of light is being incident like this. So this is the ray of light which is being incident. Okay, so from this
Yes.
one, when this ray of light, it is been incident right now here. So this will touches right now for this one. And you know that how to draw the normal right now. Can you tell me how do you draw a normal? Normal is such
It
a
should
way
pass through the center
through the
of
center of
curvature.
curvature. So that will be the center of curvature part. Okay, now from this one, with whatever angle the ray of light is being incident, with the same angle it will be reflecting back better. So if
Yes,
I'm
sir.
taking the reflected ray right now, so this will be your reflected somewhere. Now see the diagram for me carefully. So if I'm taking this is as your angle of incidence beta I, you know that angle of reflection will also be the equal to your same. Agreed? So this is your object. Image is formation is somewhere here right now. This is the center of curvature, and this is making an angle of alpha. This is making an angle of your beta, and this is making an angle of your gamma. And this one will be the normal for this one. That will be the normal. If we draw a perpendicular right now from this one, so this is also your point P, because this distance is very small. So we are neglecting the point P, and we are assuming that the curvature of that point P is exactly on this dotted line. Is that clear,
Okay,
Veda?
sir.
Now the
Yes,
distance between the object, the distance between object to the pole is known as of your object distance, and it is represented by letter U. Okay, the distance from the center of curvature to the pole, this one is known as of your radius of curvature, capital R. The distance from your image, this point to your optic center of this one, that is known as of your image distance, represented by letter V. Is that clear? So what
yes,
is
sir.
U is your object. U is your object distance. V is your image distance. V is your image distance, and F is your focal length. F is your focal length. Is that clear?
Yes, sir.
Chalo. Now consider the triangle beta. So if I am considering the triangle ONC, ONC, this is O, this is N, and this is your C, ONC. I can write that exterior angle beta will be equal to your alpha plus of your I. Can I write like this? Exterior angle beta will be equal to alpha plus of your I.
Yes, sir.
Isn't it? As angles are very small. So from this one I can get angle of incidence. Angle of incidence will be equal to how much for me? Beta minus alpha. This is my equation number 1. Is this equation clear?
Yes, sir.
Now in the same way, if I consider now the triangle CNI, see the diagram, where is C, where is N, and where is I? Center of curvature C, that normal N and I. If I'm taking that triangle right
Beta
now,
plus I.
right, gamma is equals to what I can write?
Beta plus I.
Plus of your I. Can I write like this?
Yes, sir.
Isn't it? That means from this one I can write the value of your I values will be how much from this one? I value will be equal to how much? Can you tell me? I value will be equal to how much? Gamma minus beta.
Yes, sir.
This is your equation number 2. So from 1 and 2, what I can write? Can you tell me? So from 1 and 2. So from 1 and 2, both of them are I and I. I can equate both of them.
Yes, sir.
So beta minus of your alpha will be equal to gamma minus of your beta. If I take this
Yes.
beta here, this will become for me 2 beta, that is equals to gamma. This alpha, if I take here, this will become for me positive.
Yes, sir.
Isn't it? So 2 beta is equals to your gamma plus of your alpha.
Alpha.
Plus of your alpha. As angles are very small, see the diagram, they are very small, like 2 degree, 3 degree, or something like that.
Yes,
So
sir.
we know that cos theta will be equal to your theta. So I can write here right now in the given condition. I can write this one as in terms of your tan, because if I know the small angles, tan theta can be taken as of your theta. Clear?
Yes,
This
sir.
is equal to your 2 times of your tan beta will be equal to, this one will be equal to tan gamma, plus this one will be equal to your tan of your alpha. Is that clear?
Yes, sir.
And you know what is the sign convention beta? Can you tell me? Have you remembered the sign conventions? Now tell me what is the tan beta from the given figure? Tan beta means CNPC. CNPC. C and this dotted line P and the distance between them. That will be the triangle. What is the
C.
tan beta? Vertical by horizontal kada.
Yes, sir.
Vertical is how much? NP. Horizontal
Yes,
will
sir.
become how much for me beta? C to P.
C.
C
Yes,
means
sir.
that will
C.
be equal to R, na?
Yes, sir.
because P is very, very small, that is negligible. So
Yes.
nothing but of your R. So I can write here, this will be equal to how much for me? 2 into, this can be written as here right now, this is your N into P divided by, this will be equal to your capital R. That is equals to minus tan gamma. Tan gamma you see right now. So from the given figure, if I am writing the tan gamma
Sir,
how much? INP, that is NP divided by your R.
NP by V. NP by V.
NP by V. So that will be equal to tan gamma will be equal to your NP divided by your V.
Yes.
The same way, tan alpha. Tan alpha is equal to how much from the given you see? Tan alpha is equal to ONP4. That is again
NP
NP
by
divided by U.
U.
So this will be your NP divided by your U. Now sign convention beta. I hope you remember the sign convention. All the distances are to be measured from the pole. All
Yes.
the distances are to be measured from the pole. In the direction of light positive, opposite direction to the light, it will be negative. Now the distance of objective distance will be what beta? Negative, because you are measuring in opposite direction to the ray of light. Because
Yes.
light is going from O to N and you are measuring the distance from your P to O.
Yes, sir. So
The
negative.
image distance is also negative.
Yes, sir.
And radius of curvature is also negative.
Yes, sir.
All of them are negative in the concave mirror. That means here everywhere I should be writing minus. Here it will be minus and here it will be your minus. Anything is getting cancelled beta. NP, NP and NP will get cancelled. Clear?
Yes, sir.
So now this minus and this minus also get cancelled.
Yes.
So this will be equal to how much beta? 2 by your R will be equal to 1 by
1 by V.
of your 1 by U.
Yes, sir.
Now tell me what is 2 by R beta? We know the relation R is equals to 2 times of your focal length.
Yes, sir.
So 2 by R will be equal to how much beta? You know that R by 2 is your F. So
1
2
by F.
R will be equal to how much for me? 1 by F.
1
That
by F.
you can write this one as 1 by your F is equals to 1 by V plus of your 1 by U. So this is the mirror formula.
Yes.
1 by F is equals to 1 by V plus of your 1 by U. So this is your mirror formula which you should remember in this one. Relation between focal length, image distance and as well as of your object distance is how much for me? 1 by F is equals to 1 by V plus 1 by U part. Is it clear beta?
Yes, sir.
Isn't it? That was about your mirror formula. So this formula is called as what beta for me? Mirror formula. This one is known as of your mirror formula. Or we can say it is the relation between focal length, image distance and object distance. I have written everything. What is V, what is U and F here right
Yes,
now.
sir.
U is object distance, V is image distance and F is nothing but focal length. So the relation between these three is known as of your 1 by F is equals to 1 by V plus of your 1 by U. Is that clear?
Yes, sir.
So next one faster with magnification. Magnification represented by letter M. Represented by letter M. See there, magnification is nothing but beta. It is the ratio of size of your image. It is the ratio of your size of your image to your size of your object. Is it clear? Magnification is nothing but what? Size of image by size of object. That is height of your image divided by your height of your object. This is your magnification. M is equals to your size of your image by size of your object. That will be equal to your height of image by your height of your object part of relation. Clear?
Yes, sir.
Now see this one better. Silvering is outside. So obviously I'm talking about right now for what mirror?
Concave.
Mirror formula is same even for convex beta.
Yes, sir.
For convex also same formula.
Okay, sir.
Magnification also the same condition right now, isn't it?
Okay, sir.
Now here I'm taking some object beta right now. Say here somewhere I'm taking an object right now. Say for example, this is your height of your object. This is your height of your object part. So from this one, what is happening is a ray of light from this one will be incident like this. The first ray of light will be incident like this. And that ray of light will be going parallel to this one. and another ray of light will be incident like this. Another ray of a light will be exactly incident at the center of curvature, and from there it will be reflected like this. So this will be the incident. It is incident at the pole. With whatever angle it has been incident, with the same angle it will be reflected back. The same way this
Yes.
ray of a light will be going right now here somewhere, and it is meeting somewhere here. Need to draw this now. So this is your height of your image. Ray diagram, if I'm taking, this is one ray which is passing like this, and another ray from this one, it will be like this. So another ray of a light is being incident at the center of curvature like this, at the pole. With whatever angle it is being incident, with the same angle it will be reflected back.
Okay.
Somewhere anywhere they are meeting, isn't it? So this point of meeting, image formation will take place somewhere here. Okay, so this is your height of object. So obviously this is your height of image. Everything above the principal axis will be positive. Below the principal axis will be the negative, isn't it? So this will be the objective distance beta from pole to this one. If I am taking, this will be your objective distance, and obviously this will be your image distance from pole to this one. This will be your image distance, the point of intersection. Okay, and this point where it is been meeting, this will be the focus. That is nothing but equal to your F. Is the ray diagram clear? Everything? We got height of object, we got height of your image, we know the image distance, we know the objective distance. Right now from the given figure, whatever is the normal, I am trying to write the relation right now, beta. So this will be the angle of incidence, beta, for this one. This is your angle of incidence, that is nothing but I. And this is your also angle of incidence, that is nothing but equal to your I at the pole. Isn't it? Whatever is the angle of incidence, angle of will also be the same. So I can write here tan of your I will be equal to your height of your object divided by your minus of u. Agreed? See, this one, and this one is this part, and this one is this one. This one is your I. This is your height of image, and this one is minus u. So tan theta means what? Vertical by horizontal. So tan I is equal to your height of object, this one. In the same way, tan of your another I downward also same, no? So downward also, if I am taking, this one is your height of your, this one is height of object. This one is your height of image, and this one is this one, and this one is also your same angle of your image. And here this will be equal to your V, isn't it? Minus of your V. So tan I will be equal to how much, beta? Tan I will be equal to your minus of your height of image divided by minus of V. Why minus height of image, beta? Anything below the principal axis will be negative. Anything above the principal axis will be your positive. As both of them are same, beta, can I equate them? Equating both of them, will be equal to how much, beta? Equating both of them. Equating both of them. So if I equate both of them, what I'll be getting right now? Tan I is equals to your, this one is tan I. That means height of your object, I can write here, height of your object divided by minus u is equals to minus of height of image divided by minus of v. This minus will get cancelled here right now. So this will become for me height of object divided by your height of your image will be equal to your minus of your u by v. But we need height of image. So height of image will be equal to how much, beta? Height of image divided by your height of object will be equal to minus of your v by u. Can I write like this? Now what is height of image by height of object, beta? See the definition. Height of image by height of object is known as what? Magnification. So I can write magnification m will be equal to minus of your v by u. So this is your magnification formula. Is that clear? Is that clear?
Yes, sir.
So magnification is equal to how much for me? Minus of your v by u. V is what? Image distance, and u is what? Object distance. And what is the sign convention, beta? All the distances are to be measured from the pole of your mirror, and everything above the principal axis will be positive, and below the principal axis will be your negative. Is that clear?
Yes, sir.
Next one, power. If I am talking about the power of the mirror, did you remember the formula for the power of mirror, beta? Chapara?
Yes, sir.
The mirror will be equal to how much for me? P. P is equals to the reciprocal of the focal length. If it is measured in meters, that is known as of your power. That is minus. Focal length
Yes.
negative kada, isn't it? So focal length
Yes,
of
sir.
the mirror P will be equal to minus of your F in the meters. If it is in centimeters, that will be minus of your 100 divided by focal length in your centimeters. Clear?
Yes.
Isn't it? So what is the focal length? So focal length will be equal to your 1 by V plus 1 by U, and reciprocal of the focal length will be equal to your power. And what is the unit of the power, beta? Did you remember it? Unit of the power is known as of diopter.
Yes, sir.
Diopter, represented by letter capital D. Represented by letter capital D. Is it clear?
Yes, sir.
Let us try to write the sign convention once, then we will try to go for the application of this.
Sir, but why -1? Minus
Concave mirror की focal length is how much for me? Negative kada?
negative. Okay, yes.
Isn't it?
Yes, sir.
Focal length sign convention according to the sign conventions. Okay, na?
Yes, sir.
Focal length for this one. So somewhere, anywhere, if I'm taking the focal length here right now, where is the focal length? The distance between the point where it is meeting. This is the focal length. Kada? You're measuring
Yes,
the
sir.
distance from the pole. Ray of light is coming in opposite direction. So obviously, focal length for this one is what for me?
Yes, sir. Yes.
Negative.
Negative.
For sign convention. What is the first point for the sign convention, beta? Can you tell me? First point for the sign convention is all distances are to be measured from. All distances must be measured. All distances must be measured from where, beta? Pole of your mirror, or we can say
Yes.
optic center, or we can say optic center for your lenses. Okay, pole of the mirror or optic
Yes.
center for your lenses. Next point, the distances measured. The distances measured in direction of incident light. In direction of incident ray are always taken as positive. Or always taken as positive. Clear?
Yes, sir.
Measured in opposite to that one, vice versa, negative. Isn't it? The distances measured, the distances measured in direction opposite to the incident ray are taken as negative. Okay,
Yes.
everything above principal axis will be equal to how much, beta? Everything above the principal axis. Above the principal axis. Principal axis will be
Positive.
positive. Below
Yes, sir.
it, below it,
Negative, sir.
negative. Below it will be negative. That is about your basic sign conventions, what you need to remember. Clear?
Okay, sir. Yes, sir.
Important. Magnification in terms of focal length, object distance, and image distance. Magnification in terms of what? F, U, and as well as of your V. Okay? Sure.
Yes.
I'll tell you one, the remaining you try to tell me the answer for this. See, what is the magnification formula? M is equals to minus of V by U.
Yes.
Isn't it? Now we know
HI
the
by
formula. What is the mirror formula? 1 by V is equals to 1 by
1
V
by V minus
1 by U.
plus 1.
What you do is multiply by your u on both the side. Multiply by u. U means what, beta? Object distance.
Yes.
Multiply by
Height of object.
on both sides. This will become how much for me? This will become for me how much? U by f will be equal to u by v plus of your u
One.
v, u by v plus of your u by u, isn't it?
Yes.
So this will become for me u by f will be equal to your how much for me? U by your f will be equal to u by v
U by.
plus 1.
Yes, sir.
Now take the u by v outside. So if I take u by v outside, what I'll be writing, beta? U by v will be equal to how much? U by v will be equal to, this will become for me u by f minus 1. Na?
Yes.
U by f minus of your f. Can I write like this?
Yes, sir.
Isn't it? So magnification I can write here right now. M will be equal to your how much? M will therefore M will be equal to minus of v value. How much you got? U minus f divided by your f. Now if I remove this minus sign, I can write m is equals to f minus of u divided by your f. So this is the magnification in terms of focal length and as well as of your object distance. Focal length and in terms of your object distance, this will be the formula. This is basic formula magnification. M is equal to minus of v by u. In terms of focal length and object distance, it will be your f minus u divided by your f. Is it clear?
Okay, sir. Yes.
Any doubt in this one?
No, sir.
Clear?
Yes.
Next one. Now if I'm writing the next one, beta. Now multiply on both sides by what? V.
Yes.
So
Yes.
if I multiply on both the sides by your V. So what is the mirror formula for me? 1 by f is equals to 1 by v plus 1 by u. That means this will become for me v by your f. V by your
Yes.
f equals to v by
V
v.
by V
This will become for
plus I by
v
B
by
by
v
U.
plus of your v by u. That means
Yes.
v by your f will be equal to 1 plus v by u. That means v by u will become how much for me, beta?
Sir, will become V by F minus 1.
V by f minus 1. That means v minus f divided by f.
Yes.
Therefore, magnification will become how much for me? What is our magnification? Therefore, magnification is minus of your v by u. That is equals to minus. This is v minus f divided by your f. That means
Yes.
magnification will become for me, if I remove the minus, f minus of v divided by
Divided by
your
F.
f. So this
Yes.
will be the magnification in terms of focal length and as well as of your image distance. M is equals to this one. Clear?
Yes, sir.
Isn't
Yes.
it? Have you done all the types of magnifications, beta? Linear magnification, longitudinal magnification, aerial magnification, volume magnification, image formation by the concave and convex mirror. Even graphs
Yes, sir. Yes, sir.
graphs కూడా చెప్పేశారా స్ట్రైట్ లైన్ గ్రాఫ్స్ ఎలా డ్రా చేయాలి అన్నిటికీ
ఒక్క నిమిషం సార్, I'm just checking out.
ఒకసారి చూడు.
Yes. Yes, sir. గ్రాఫ్ కూడా ఇచ్చారు సార్. గ్రాఫ్స్ ఇచ్చారు సార్.
ఇంకేమేం చేశారు రిఫ్లెక్షన్ లో? ఇవన్నీ చేశారా? టైప్స్ ఆఫ్ మ్యాగ్నిఫికేషన్ చేశారా? లాంగిట్యూడినల్ మ్యాగ్నిఫికేషన్, ఏరియల్ మ్యాగ్నిఫికేషన్.
Yes, sir. Yes, sir.
బాగా ఫాస్ట్ అయిపోతుంది అట్లయితే. వెలాసిటీ ఆఫ్
రిఫ్రాక్షన్ ఇప్పుడైతే రిఫ్రాక్షన్ చేస్తున్నాం సార్ ఇంకా కూడా.
సో రిఫ్రాక్షన్ అంటే రిఫ్లెక్షన్ చాలా పెద్ద టాపిక్ అది అయిపోయినట్టు. Okay, chalo.
ఇప్పుడైతే క్రిటికల్ యాంగిల్ చేస్తున్నాం సార్.
Okay, fine.
Yes.
Next topic దీనిలో పెట్టుకున్నాను ఒకసారి. Velocity of image. Mirror idea ఉంది కదా, plane mirror. What is the velocity of the plane mirror along x-axis?
Yes.
What is the formula?
Sir, VI is equals to 2VM.
Velocity of image is equals to 2 times of velocity of mirror minus velocity of object. So in the same way, velocity of image now due to the spherical mirrors మాట్లాడుతున్నాం మనం.
Yes.
Isn't it? That was for your what mirrors? Plane mirror.
Plane mirrors.
This was, now this is for your spherical mirror. Spherical mirror means both the convex mirror and as well as of your concave mirror.
Yes.
So for both of them, we'll be talking right now here. Now see here, I'm just roughly drawing the diagram. This is your axis and it is silvered on the outer side. Okay, and here this is your object beta, and object is moving in the front direction with a velocity of this one, and this is the pole. What type of your mirror it is beta?
Concave.
Concave. Now see, if I'm talking about for a point object, moving along principal axis, So we are talking about for what beta? Point object is right now moving along your principal axis. We know the focal length of the mirror beta, 1 by f will be equal to 1 by v plus 1 by u.
1 by u.
Focal length is a constant beta every time. Okay, so if I differentiate this one with respect to time, differentiate with respect to your time, f is a constant. Differentiation of any constant will be equal to how much? 0. Now chain rule if I'm applying right now for this one, this will be 1 by, this will become v square into dv by your dt. This one is nothing but of your plus, this will be minus of 1 by u square into your du divided by your dt. What is v beta here? What is v? V is image distance. V is your image distance. Don't take it as velocity.
Yes.
And u is what? Your object distance. So this one is your object distance. Now see, so distance by time will give me what beta?
Displacement.
Distance by velocity by your, this is nothing but a distance traveled by time.
Sorry, velocity, yes.
Velocity kada. So this can be written as minus of 1 by v square into dv by dt is nothing but what? Velocity of image and raskocha.
Yes.
Plus minus minus, this one is 1 by u square into du by dt is nothing but what beta? Velocity of your object. This minus term if I take on this side, this will become for me how much beta? Can you tell me? That will become for me how much? Can you tell me what will be the relation right now for that one? Tell me. If I take this minus term on this side, this will become for me what? Positive kada?
Yes sir, 1 by v.
1 by v square into, this is your velocity of your image, that is equals to minus of 1 by u square into velocity of object.
Yes.
If I need to calculate velocity of image, means velocity of image will be equal to minus of this v square will go up here right now. So it is v square divided by your u square into velocity of an object. Can I write like this?
Yes sir.
So velocity of image in which direction beta? Along the principal axis when it is being moving, I can calculate by the formula velocity of your image will be equal to your minus of v by u into your v naught. What is vi beta here? What is vi? Vi is equals to velocity of your image, velocity of your image, and v naught is known as of your velocity of your object, velocity of your object. What is v beta? V is your image distance, v is your image distance in this formula, and u is equals to your object distance, u is equals to object distance. Now you know what is v by u beta? Can you tell me? What is v by u? What is
sir,
v by u? Magnification,
it is, image distance, object distance.
Okay, so velocity of your image.
Sir, it is the magnification.
Yeah, so this will become for me minus of your m square into velocity of object also. Can I write?
Yes.
So this can also be written like this. So velocity of your image will also be equal to minus of this one. Okay, yes. Now is that clear? So this is one of the very important formula you need to remember. When the object is moving along the principal axis, then how do you write the relation for that one? Is that clear? Any
Yes,
doubt in
sir.
this one?
Got it, sir.
Clear now? So velocity of image along your x-axis. If it is moving along x-axis, this will be the formula. We are even having along y-axis also better. That we'll try to do in the extra classes because we have this weekend examination for you, the refraction. So I want little bit hurry in starting you at the refraction part of relation for your weekend examination. Okay.
Okay, sir.
Sure. So we have time. Do you have any chemistry
Yes,
class right
sir.
now, or can we continue for a little bit long? Any chances there?
Sir, I have chemistry class, sir.
What?
Tomorrow morning, can we have, sir? Can we take one
Morning
class?
one class we can have better for the refraction if it is possible. Okay.
Yes, sir.
Then
Yes,
I'll
sir.
keep the
Tomorrow
full
morning
stop
we'll
right
take.
now here. Morning 7 to 8 will make one class.
Okay, sir.
Okay. So I hope you got
Yes.
a rough idea related to the mirrors because this basic knowledge also is much required for your refraction also. Otherwise it will be difficult. But all the maximum points have been covered, but still some more extra points also we need to be covered that we can do in some extra classes.
Okay, sir.
Okay. So I'm ending the session better.
Okay, sir.
Okay. So take
Thank
care.
you, sir. Bye, sir.